So electrode potential and the transition metal. Actually, two topics are different, but because they are related to each other, so that's why the questions which I include in this assignment, you will find questions are related to electrode potential as well as the transition elements. So first one, when an alkene is added to solution of a potassium manganate 7, the purple solution turns colorless. So originally it was purple and then it turned into a colorless. So we have, in terms of electron transfer and oxidation number, how does the manganese change in this reaction? So Mn, which is 7, that is purple in color. But Mn plus 2 is colorless. So what will happen to oxidation number of Mn? Originally it was plus 7, it turned into 2. So plus 7 turned into 2, it means it decreased. So either B can be an answer or D can be an answer. Because two possibilities are there, it should decrease. Then what happened to Mn? Like what should happen? Mn was plus 7 and it has turned into Mn plus 2. So how plus 7 can turn into plus 2? It means it will gain electron, and how many electron it will gain? 5 electrons. So when it takes 5 electron, the charge which was plus 7 now turned into plus 2. So it gains electron and the oxidation number decreases. That's why B is the right answer. Then question 2, the standard hydrogen electrodes use an electrode of platinum, and that is coated with finely divided form of a metal called platinum black. What is the purpose of this coating? Because if you are using a fine or a small surface area, like a small particle size, so it will have a large surface area. So when it will have a large surface area, it increases the rate of equilibrium between hydrogen gas and, like, basically what might happen, the hydrogen molecule turn into hydrogen ion by loss of electron, or other way around as a reversible. So what is the advantage of having this finely divided form of a metal, platinum black? So it will have small particle size, large surface area. So it will increase the rate of the reaction. So increase the rate of reaction. That's why option A will be the right answer. In question 3, part A, an electrochemical cell is set up to measure the cell voltage. What is the cell diagram of this reaction? So how we can identify or how we can work out the cell diagram? So for iron, it turned into iron to iron. So this change is oxidation. And for tin, it is a reduction. So element, because it's in a cell, the substance which oxidation happens should be on the left hand side, and the substance which reduction happens should be on the right hand side. And two are separated by the lines which known as the salt bridge. So what happened on the left hand side? On the left hand side, the iron, which is solid, will turn into iron. The solution, like what electrode we have, then what is the electrolyte? And then on the right hand side, what electrolyte we have, like tin is there, and the electrode should also made up of tin. So tin ion plus 2, because here what is happening? Iron turn into iron 2 and tin ion turn into tin atom. So that is the electrode. On the left hand side, that is the electrolyte, the solution. And this one is electrode, electrolyte, and then electrode. So which one it match with? The state for the ion should be aqueous. So it matches with option C. So C is the right answer. Then the next part, the standard electrode potential for iron is minus 0.44, and for the cell voltage is 0.30. What is the standard electrode potential of a tin? So how we can work out? There are two ways. We can use reduction minus oxidation is equals to electrode potential. So remember, from redox, like reduction minus oxidation is equals to the cell voltage. So which one reduction is happening? As you can see, for tin I plus 2 turn into, so that is reduction happen. And for iron, oxidation happen. So reduction minus oxidation is equals to electrode potential of a cell. Reduction happen for tin, so that is we want to find, minus the oxidation happen for iron, the oxidation that is 0.30, equals to the cell voltage. The cell voltage is minus 0.44. So 0.4, sorry, this was reduction minus oxidation. So this is the voltage of iron, electrode potential of iron, which is given as minus 0.44. And the voltage of a cell, the reaction is 0.30. When we simplify, x minus minus is plus, 0.44 is equals to 0.30. And it is positive, it will move other side, so it will be negative. So x is equals to 0.30 minus 0.44. When we simplify, that will be minus 0.14 volt. So the electrode potential will be equal to minus 0.14. That's why B will be the right answer. So it's always the reduction minus oxidation is equals to cell voltage. So how we identify which one reduction and which one oxidation, that we have to check the equation. When you check the equation, you can clearly see that for iron to iron 3, it's oxidation. And tin plus 2 to tin atom, it's reduction. So the voltage of reduction minus the voltage of oxidation is always equals to the cell voltage. So this was X, this was minus 0.44, and this was 0.3. So we simplify, that will be minus 0.14. Or there's also another way, electrode potential on the left hand side minus electrode potential on the right hand side will give us the cell voltage. That also can be done. But I prefer to use this method as it's always valid according to the question. So in a hydrogen oxygen fuel cell, it can operate in acidic or it can operate in alkaline medium. What is the reaction at anode in an alkaline hydrogen oxygen fuel cell? So first, because this reaction can happen in acidic condition, it can also happen in alkaline condition, both. So which one involve alkaline condition, like not as a product, as a reactant? So either B can be an answer or D can be an answer, because here why A and C cannot be, because hydroxide is given as a product. So it means we did this like hydrogen oxygen fuel cell was there in alkaline condition. So if it was there in alkaline condition, it means there should be OH present in the reactant side. So when we work out, and we want the reaction at anode. So what basically happen in a hydrogen fuel cell, like we have electrodes. The hydrogen is there, the hydrogen molecule, it will dissociate or it will break down into the proton, like H2 molecule is there. It will break down into 2 proton plus 2 electron. The electron will travel in the external circuit. So electron will travel in the external circuit. So there will be protons here, electron travel in the external circuit. So proton form here, electron in that combined with oxygen to give off water. That is an overall equation for this, even in acidic condition or alkaline condition. It's like 2H2 plus O2 gives 2H2O. That's always the case. In terms of movement of electron, this is a negative terminal. This is a positive terminal. But what happened in terms of loss or gain of electron? So at cathode, like oxygen, what happened? Oxygen will lose electron here. So why A is incorrect? Because why it is incorrect? Because this is what happened at cathode. In the alkaline condition, the water molecule, this negative and positive is in terms of movement of electron. But the side where oxygen is added, that side is known as a cathode. So don't be confused with the positive and the cathode. Why it is this side is named as cathode and the other side is anode? Because at cathode, there is always a gain of electron. So reduction always happen at cathode. So in terms of loss or gain of electron, this is reduction, as is gaining electron, and this is oxidation. So oxidation happen at anode, where is a loss of electron, and reduction happen at cathode. So in terms of oxidation and reduction, the side where we have hydrogen is always anode, and the side where we have oxygen, that is cathode. But in terms of movement of electron, that electrode, because electrons are negative, so they move from negative to positive. So in terms of movement of electron, this is called a negative plate, and the other one is a positive plate. So this oxygen reaction happen at cathode. It is not happening at anode. So that's why A cannot be a right answer. Then what about B? B does not involve hydrogen, because hydrogen should be involved. Hydrogen will break down and give off proton. So that's why B is also incorrect. Why C is incorrect? Because like water molecules are here gaining electron, because this is a reverse of the cathode reaction. Like what actually happened, that is given opposite of the cathode reaction. And here what happened when hydrogen in an alkaline medium, it will produce water and give off 2 electrons. So electron will travel and oxygen will gain those electrons. That's why D is the right answer. So remember, two things are important. One is anode and cathode. In a fuel cell, at anode we'll always have hydrogen, and at cathode we'll always have oxygen. That is one thing. But in terms of plates, the negative plate is the where hydrogen is there, and a positive plate where oxygen. Because the plates are due to the movement of electron, and anode and cathode are due to oxidation and reduction. This is the iodine and thiosulfate peroxo disulfate ion reaction is there. This reaction is catalyzed by iron 2. And this is a homogeneous catalyst. The homogeneous catalyst, because they can easily oxidize and reduce. Because this is a negative, this one is also negative. So like charges repel. So these molecules or ions cannot collide with each other as they have a like charge. So first, what will happen? The iron might be because here iodine molecule is turning, iodide ion turning to iodine molecule. It's a loss of electron. And here this gain electron. So first, how this reaction, how iron 2 can catalyze this. So iron 2 will react with S2O8, and then which is peroxo disulfate ion. And as a result, because they are oppositely charged, iron will lose and this will gain. So iron will turn into +3 and it will form 2SO4 with a charge -2. And this iron 3 will react with iodide ion, and iodine will lose electron, iron 3 will gain that electron back. So it will turn into +2 and it produce iodine molecule. So it's a homogeneous catalyst because the catalyst is having a same phase as the reactant. So this catalyst is effective because it can readily oxidize and then reduce. Like iron 2 can oxidize to iron 3 and then it reduce back. That's why this is suitable. For this, you have to use the which of these has the greatest number of unpaired electron. So this vanadium is there 23, chromium is there 24, iron is there, manganese is there. So first the atomic numbers, because using their atomic number you can work out, like vanadium is there 23, chromium is 24, manganese is 25, and then iron is 26. Then we write the electronic configuration. It will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. So 20 are arranged. For all of them, it will be like this because 20 are there. Then it will be 3d4. But then what will happen for a chromium specifically? Because half-filled orbitals are more stable. The half-filled orbitals are more stable than the partially filled orbital. So here one of the electron from S will jump to D. So for chromium, that like this till this point it is same. So for chromium, what will happen? It will be 4s1 and it will be 3d5. So how many unpaired electron? Because 5 here and 6 unpaired electron. When we write for iron, it will be 4s2 and then it will be 3d because 26 are there. So 3d 6. Here, because D is having a 6 electron in D means these 5 orbitals are there, 1, 2, 3, 4, and 5. So first 1, 2, 3, 4, 5, and then there will be a 6. So there will be 4 unpaired electrons. So 4 unpaired electrons will be there. When we check for manganese, this will make 20 and then 3d5. So there are 5 unpaired for, because this is complete, and this will be 3d 323 because we want to make. So there will be 3 unpaired electrons. So for chromium, why it is 6? Because first 4 and then because one of the electron jumps, it creates 2 unpaired. So 4s is having one unpaired, like unpaired electron, and each of the 3d 1, 2, 3, 4, and 5. So there are total 6. That's why chromium is the right answer. So nickel is classified as a transition metal. This is because it's a D block element. It's not true because like zinc and scandium also are D block element, but they're not transition elements. It has partially filled d orbital when it is a compound is a transition element. Why this is incorrect? Because element can be in D, but not be transition. That's why A is not right. And why B is not right? Because some elements have partially filled d orbital, but they are not transition element. Like scandium is there, so it's having a partially filled d orbital, but it's not classified as a transition element. So second statement is not valid for all. Form stable ions with partially filled, that is true. Like when they have partially filled d orbital, but their ions are stable, so C is the right answer. And form stable compound in which has different oxidation state. Why statement D is incorrect? Because elements can form stable compound with different oxidation states, but that does not mean they are transition. To be a transition element, they should form a stable ion with a partially filled d orbital. So platinum, it's having the coordination number 4, chromium also coordination number 4. The platinum, what is the tendency of a platinum? Platinum has a tendency to form the square planars. So platinum complexes are square planar, and then chromium will be there, that will be tetrahedral. Because when coordination number is 4, there are two possibilities. It will be either a square planar or a tetrahedral. So platinum always square planar. And here for chromium, it is a tetrahedral. That's why D is the right answer. The next, what is the bonding between the ligand and the central atom? So they always have a dative bond. So between the complex, bonding in both complexes is dative. Ionic bond is there between a complex and, like example, if we have, say, platinum complex is there, which is NH3 and then Cl2. And as there will be a charge on this complex, or it might not have any charge here, like it does not have charge, but a chromium complex is having a charge of -1. Each chromium is +3 and each chloride is -1. So 4 will be -4, charge -1. So then it will be attracted with any other substance, maybe silver, any. So between them is ionic, but within the complex, the ligand and the central atom is always a dative bond. So B will be the right answer. So this is a structure question. The diagram summarize some reactions are there. So first we have copper sulfate, then it turned into copper 1 iodide. It means it's a reduction because copper 2 sulfate turned into copper iodide. Then we add sulfuric acid. So copper 1 iodide, if we add sulfuric acid, it will form copper. So it's a disproportion reaction. The copper metal is formed and copper 2 ion is formed. If we add ammonia, it's a colorless solution. It's forming a complex of copper 1. And if we shake vigorously, it will be oxidized to copper 2. The same complex, only the oxidation number change. As the oxidation number change, the color of a substance will also change. So it will become copper +2. And copper sulfate, we add ammonia, so it will form a pale blue solid. That is due to formation of a copper hydroxide. And when we heat, the copper hydroxide dissociate, like break down into copper oxide and plus water. So this will be copper oxide. And then copper oxide plus nitric acid, it will give copper nitrate. So this is a summary. Like we have to identify these substances which are formed. Identify by name, including oxidation state or a formula of species in the sequence. So as you can see, we have P, Q, R, S, T, V, and W. So what is actually P? P is the copper. You just identify P is the copper. What about Q? Q is basically a copper 2 solution is there. The solution contain copper 2 ion. So Cu, H2O and a bracket 6 and then +2. And R is what? R is copper hydroxide, S is copper oxide, because the copper hydroxide, this was when we add aqueous ammonia, it turned into, there will be an first acid-base reaction due to which it turned into copper hydroxide. When we heat copper hydroxide, it gives off copper oxide plus water, and that copper oxide is black in color. And copper oxide we add, so it will turn into copper nitrate. So the substances which we have here, we have like P is a copper, Q is copper complex, copper 2 complex, R is copper hydroxide, then S is copper oxide, T is the complex of the copper 2 with ammonia, and then V is actually the complex of copper 1, and then W is again, you can mention like turn into copper nitrate, which mainly contain copper ion. So it will be a complex of copper.